What if the secret to surviving on Mars is already discovered but hidden in plain sight? To seek that answer, we're Team Sirius from Bangladesh, the explorers of data and dreamers of space, built something extraordinary. Meet our team members, Ahmed Fahmid Alvi, team lead, AI and backend developer, UI and UX designer Janatul Ferdows Min, Fahim Faisal Shomi, graphic designer, Shifa Tabassum, data analyst, and Sadman Saqib, video editor. Together, we believe data is not just numbers, it is the story of life in space waiting to be told. To uncover that story, we must first gather the fragments of knowledge left across time. For decades, NASA has studied how plants, microbes, and humans adapt in space. The answers exist, but they are buried in thousands of papers. Astronauts, scientists, even students struggle to find what they need. The problem is not knowledge, it is access. And when survival on Mars depends on biology, access becomes everything.
In that access, we see possibility. Our answer is the Space Biology Knowledge Engine, a smart and accessible system that transforms decades of research into living searchable map that turns complexity into clarity and data into discovery. It starts with one thing, landing and search and asking the question. The journey begins when a user arrives on the website. They can type any question in natural language. For example, how does microgravity affect bone density in rodents? Our smart machine learning model intelligently parses the query, and by understanding words, it picks the best filters for your search. It gathers data from key sources like NASA Data Portal, OSDR, GeneLab, PMC, ADS, SB Publication, NASA Biological and Physical Sciences, NSL, SL, and Textbook. Done questioning, results pairs instant answers, and AI summaries arrives. Once the search is complete, the website shows a list of most relevant biology and space papers that match your question. Our model reads these papers and gives a short summary of the main points so you understand the paper quickly without reading it all. You also see links to the original NASA websites where the biology and space paper come from and can download the real paper. You can filter results by organization, mission, essay type, or year to narrow down your search. If you click View Paper, you get more details like overview, data and methods, AI insights, and can download the full paper. And by clicking on the source, you can visit the actual website. But discovery doesn't stop with text. Here comes the knowledge graph exploration. Seeing connections? Based on your search, the system builds an interactive knowledge graph. The graph has connected nodes representing papers, datasets, or missions. You can zoom and pan around the graph. You can filter nodes by types like only paper or only missions. Clicking a paper node shows a summary and important details of the paper. Also can download view source to go to the original source. Clicking a mission node will show mission detail and a link to its Wikipedia page for further information. Also, you can download the whole knowledge graph in JSON format. From the graph, the journey continues at Dataset Explorer, diving into the data. After exploring the graph, you can see all related dataset into one page. It shows dataset title, mission, type, number of samples, and size. You can click on a dataset to see its summary, preview data, and metadata, and can also download the dataset directly from the NASA website. Finally, the engine offers a comparison workspace. You can compare multiple papers or datasets side by side. Our model compares main findings and makes a summary explaining how the studies are similar or different. It shows supporting evidence so you know where the AI found the information. You also see difference in source, year, duration, and key findings side by side in a table. You can also name your workspace like mass musculus comparison and download it as a PDF or JSON file to share.
This is not just a tool, it is a bridge to humanity's future in space. Imagine astronauts guided by instant biological insights, doctors on Mars protecting human health, and students on Earth inspired by discoveries beyond our world. This is the beginning of open space biology for all. With your support, the Space Biology Knowledge Engine can carry us from Earth to the Moon and onward to Mars. To thrive beyond our planet, we must first understand how life adapts beyond it. And together we will.